Alright, so in this problem, I have 5 to the power of x is equal to 0. So, I obviously want to find the value of x here. So for my solution, well, I'm going to first start by, let's start by trying out values of x. So if I have 5 to the power of 1, for example, this is equal to 5, right? If I have 5 to the power of, let's do 1 less than 1, 0. Well, any number to the power of 0 is 1. If I have 5 to the power of negative 1, this is going to be 1/5. If I have 5 to the power of negative 2, this is going to be 1 over 25. Let's say I have 5 to the power of negative 10. This is going to be 1 over 5 to the power of 10. So you see, as the exponent keeps on decreasing and decreasing and decreasing, well, it's approaching infinity, right? But will it ever reach infinity? Well, let's see if we can even find a value of x that makes this equal to 0. So, the first step I'm going to do is take the log on both sides. So I have log 5 to the power of x is equal to log of 0. Now, if I have something in the form log a to the power of b, I can move this exponent b to the front. So this is going to equal b times log a. So in this case, I have log 5 to the power of x. And I can move x here to the front. So now I have x times log 5 is equal to log 0. Now, if I divide both sides by log 5, these two cancel out, and I get x is equal to log 0 over log 5. Now log 5, this is equal to 0.6990, and log 0, this is actually undefined, meaning I have x is equal to undefined over 0.6990. Well, if something's undefined and you divide it by a number, it's still going to be undefined. So, meaning the value of x is undefined. Alright, so in this problem, I have m to the power of 3 plus m is equal to 350. So the first thing I'm going to do is subtract 350 on both sides. So these two cancel out, and now I have m to the power of 3 plus m minus 350 is equal to 0. Now, m to the power of 3 plus m minus 350, well, I can rewrite 350 here as negative 343 minus 7. So now I have m to the power of 3 minus 347 plus m minus 7 is equal to 0. Well, m to the power of 3 minus 347, this is the same thing as m to the power of 3 minus 7 to the power of 3. And I have this plus m minus 7. Now, if I have something in the form a to the power of 3 minus b to the power of 3, this is the same thing as a minus b times a squared plus ab plus b squared. So in this case, a is m and b is 7. So I have m minus 7 times m squared plus 7m plus 7 squared. I have this plus m minus 7 is equal to 0. Now, 7 squared, this is the same thing as 49, so I have m minus 7 times m squared plus 7m plus 49. plus m minus 7 is equal to 0. Now if I factor out m minus 7, I have m minus 7 times m squared plus 7m plus 49 plus 1, which is equal to 50. So this is equal to 0. So now this gives me two equations. I have m minus 7 is equal to 0, and I have m squared plus 7m plus 50 is equal to 0. So m minus 7 equals 0. This is the same thing as m equals 7, so this is already one solution of m. And m squared plus 7m plus 50, you have to use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So this is the same thing as negative 7 plus or minus the square root of 7 squared, which is 49, minus 4 times a, which is 1, times c, which is 50. And if you notice, this is the same thing as the square root of 49 minus 200, which is going to be a negative number, meaning this won't work, and my only solution is m equals 7. Alright, so in this problem, I have 2 to the power of 24 minus 16. So to solve it, I'm going to first rewrite 2 to the power of 24 here as 2 to the power of 12 times 2. And if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So 2 to the power of 12 times 2, that's going to equal 2 to the power of 12 to the power of 2. And I have this minus 16, which is the same thing as 4 to the power of 2. Now, if I have something in form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, a is 2 to the power of 12, and b is 4. So I have 2 to the power of 12 plus 4 times 2 to the power of 12 minus 4. 2 to the power of 12, well, 2 to the power of 10, this is 1024. So 2 to the power of 11, this is going to be double of 1004, which is 2048. Meaning 2 to the power of 12, this is double of 2048, which is 4096. So now I have 4096 plus 4 times 4096 minus 4. Now this is the same thing as 5000 times 4092. Or sorry, this is the same thing as 4100 times 4092, which is the same thing as 4000 plus 100 times 4000 plus 92. So now to solve this, I'm simply going to just distribute. So I have 4000 here. If I distribute, I have 4000 times 4000 plus 4000 times 92 plus, now if I distribute the 100 times 4000 plus 100 times 92. Now 4000 times 4000, that's 4000 squared, plus 4000 times 92. 4000 times 92, that's going to be equal to, 1 second, 368,000 plus 100 times 4,000, that's going to be 400,000 plus 100 times 92, that's 9,200. Now 4,000 squared, that's going to be 16 million. So I have this plus 368,000 plus 400,000 plus 9,200 is 400,000, 9,200. Sorry, 409,200. So now I have 16 million plus 368,000, which is 16,368,000, but I have plus 409,200. So this is going to be 700,000, 720. Sorry, 200. So this is my answer.
So in this video, I'm going to be solving the equation x to the power of x to the power of 3 is equal to 729. So to solve this, what I'm first going to do is take the power of 3 on both sides. So I get x to the power of x to the power of 3 to the power of 3 is equal to 729 to the power of 3. Now, if I have something in the form a to the power of m to the power of n, this is the same thing as a to the power of m times n. Now, m times n, I can also rewrite as n times m. And if something in the form a to the power of m to the power of n is equal to a to the power of m times n, then a to the power of n times m should also equal to a to the power of n to the power of n. So in simpler terms, a to the power of m to the power of n is equal to a to the power of n to the power of n. So now from here, I have x to the power of x to the power of 3 to the power of 3, and I can think of x to the power of 3 as m and 3 as n. So if I switch the places of these two, I get x to the power of 3 to the power of x to the power of 3. And remember, this is equal to 729 to the power of 3. Now, from here, I'm going to let x to the power of 3 equal to the variable y. So I get y to the power of y is equal to 729 to the power of 3. Now, I can simplify 729 to the power of 3. So 729 is the same thing as, 729, let's find some factors of this. So a factor of 729, let's try to divide this by 3. 729 divided by 3, we have 2 over here, so we get 6. We subtract 7 with 6, we get 1. We bring that to 2. 3 times 4 is 12. And now we bring that to 9. 3 times 3 is 9. So I get 729 is equal to 243 times 3. Now, 243, if I divide this by 3, I get 81. So I have this times 3 times 81. Or sorry, I have 3 times 3 times 81. And 81 is the same thing as 3 to the power of 4. So I have 3 times 3 times 3 to the power of 4, which is equal to 3 to the power of 6. Meaning 729 is the same thing as 3 to the power of 6. And 3 to the power of 6, I can break that down into 3 squared times 3 squared times 3 squared, which is equal to 9 to the power of 3. So I'm going to replace 9 to the power of 3 with 729. So I get y to the power of y is equal to 9 to the power of 3 to the power of 3. And the reason I did this is because 9 to the power of 3 to the power of 3 is the same thing as 9 to the power of 3 times 3. And 3 times 3 is 9. So I get y to the power of y is equal to 9 to the power of 9. And now I can use the property a to the power of a is equal to, if a to the power of a is equal to b to the power of b, this means that a equals b. So in this case, y is equal to 9. Now, recall how I let x to the power of 3 equal to y. Meaning, I get x to the power of 3 is equal to 9. So now to solve this, I'm going to take the cube root on both sides. So I get the cube root of x to the power of 3 is equal to the cube root of 9. Now the cube root of x to the power of 3 is simply just x. So I get x is equal to the cube root of 9. And this is the same thing as 9 to the power of 1/3.